So what we're going to do now is we're going to talk about, so spread for a box plot, right? Spread for a box plot. We talk about the interquartile range and range. For like a histogram or a stem plot, we can talk about that range, but there's another way we talk about spread. When you talk about spread, and usually when you talk about mean, you're going to talk about standard deviation. And standard deviation is symbolized by a little s. Sometimes you'll see a little x there. And s measures spread. Okay? So S measures spread about the mean and should be used only when the mean is chosen as the measure of center. So what that means is, if you choose the median, you should not be talking about the standard deviation. Median and standard deviation do not go together. It is mean and, it's mean and standard deviation, median and the 5-number summary. That is very important. Yes, you will lose points. If you talk about standard deviation in a box plot, no. And it's not just a box plot, but that 5-number summary. That's not, you won't get very far. Okay, S, which is standard deviation, equals 0 only when there is no spread. You guys, what that means is that this happens only when all the observations have the same value. As soon as you change a value, you could have 22 17s in a row, okay? As long as you don't have another number, your standard deviation is 0. But as soon as you put like an 18 in there, or you put a 16, or heavens forbid, you put a 49, your standard deviation changes. So the only time it is 0 is when every observation, every piece of data is the same value, okay? That's the only time standard deviation is 0. I'm going to tell you that they love that type of question. True or false, right? It's like one of those. I think this year, well, they were supposed to do it last year, but I don't know. You know those 1 questions where it says 1 only, 2 only, 3 only? In the past, they loved those type of questions, but I think they're trying to get away from them. So I don't know if it's happening this year or next year, okay? So, S, standard deviation, like the mean, is non-resistant. What that means is low outliers, high outliers, skewedness, the spread is going to be, the standard deviation is going to be affected by that. So the mean is always pulled up by the tail, wherever the tail is of your histogram. The mean is pulled up, so is the standard deviation. That standard deviation is affected by the skewness of the data, just like the mean is, okay? The median is resistant to that. The 5-number summary is resistant to that. The standard deviation and mean is not. So what you need to know is strong skewness. Skewness is a word. I just need you to know that. If you type it in Word, they do not like it, but it is a word. And a few outliers can make S very large. So, S is spread. You only use it with the mean. The only time it's 0 is when every number in the data set that you are working with is the same value. S is not resistant, and it will be very large if it is a very strong skewedness or you have a few outliers. Okay? Now, S squared means variance. It means how much does your data vary from the mean. So S squared, you can't see that, now you can. S squared means variance. S equals the square root of S squared, and that is standard deviation. You guys, a lot of times they will give you the variance and they will ask about standard deviation. They do that a lot. They love to talk about variance because that variance is, because it's variance. How much does it vary? And then they'll say, they'll give you variance and then they'll ask you a standard deviation question. So you need to know, oh, variance, that's S squared. So to find standard deviation, I take the square root of it. That's my standard deviation, okay? So the standard deviation measures spread, which we talked about, and you only use it with the mean by looking at how far the observations, you guys are all the data points, however you want to look at it, the observations are from the mean. And if you're thinking about standard deviation meaning squared variance, how much does it vary away from the mean? We're really gonna talk about that in chapter 2 because we start talking about how much it varies from the mean. Okay. Now, there's a formula. You are going to have to do this for me once by hand. Okay? I don't give you a lot of them, but you will have to do it once by hand because this is what you need to think about the AP exam. Okay? They know that you have a calculator. They're hoping that you have a calculator. They're thinking that you are going to use the calculator. Now, the very first exam in 1997, they did not allow calculators. No calculator. Maybe like a for function, to find the mean and stuff, but no calculators. Now they expect you to have that graphing calculator and they expect you to use it. The problem is that it's not really a problem, but what the expectation is you understand the keys that you are pushing, you understand what they are doing. So they might ask you a question about the formula. They know you're going to use your calculator. They know you're going to get an answer, but do you understand what the calculator did? So I'm going to give you a formula and you're going to have to perform it by hand. Not the little type math, but you're going to have to do it by hand and show me. So S squared. So you don't ever start with standard deviation. There isn't a standard deviation formula. It's a variance formula. And it means observation 1 minus the mean, which is X bar, the mean of this particular thing, and we're going to square it. You square it because you can't really have negative numbers. Observation 2 minus X bar, which is the mean, squared, plus the third observation minus the X bar, squared, plus, I've just put dots, plus the last observation, which we don't know, minus X bar squared, all divided by n minus 1. We call n minus 1 degrees of freedom. And then you just need to remember the final step. So this is variance. This is how you find variance. But what I asked you to find would be standard deviation. So to find standard deviation, you take S equals the square root of S squared. So whatever you get for your variance, you take the square root of it. When you get your final standard deviation answer, you want to round it to 4 places out. The more you round, the further you are away from that spread. You're making that standard deviation bigger. So round off error, always 4 decimal places out. I believe calculus uses 3 decimal places. Is that what Miss?
Oh, I have no clue.
Okay. Okay. Yeah, that's good.
Yes, she does. Okay.
3 out. Calculus is 3 out. We go 4 out in stats. Okay. In our case, it's called round off error. We want to be really good with round off error. Okay. Now, we're going to practice one of these. Of course we are. But when I practice, just so you know, which I don't think I'm going to give you 10 observations to do because that makes a little bit more work. So we're going to do it by hand, but not as many. Now, so we have the 5-number summary, and the 5-number summary goes with a box plot. That's how you use a box plot. And then we have the mean and the standard deviation. So which one should you use? Should you use the 5-number summary or should you use the mean and the standard deviation? It really depends on the shape of the graph, okay? So the shape, so if you have skewed data, we want to use the 5-number summary. You guys, that 5-number summary, because it deals with the median, I can't believe I couldn't get that in there. The 5-number summary is better because it deals with the median. Thank you. Sorry, guys. Didn't mean to, you know. We're almost done because I'm getting close to it, right? Is better because the median is resistant to outliers and to that skewedness, right? Use the mean and standard deviation. For symmetric distributions free of outliers. So when you say something's roughly symmetrical, the AP graders are looking for you to use the mean and the standard deviation. If you say something's skewed to the right or skewed to the left or have outliers, they're going to assume that you are going to use the 5-number summary because you're going to want to talk about those outliers. You're going to want to talk about the 50% where 50% of the data lie. You guys, this is really important. You need to be able to look at a graph, a distribution, histogram, box plot, stem plot, dot plot, whatever, and decide if you should use the 5-number summary or the mean and the standard deviation. As soon as you use the word, oh, this is skewed, right? Even if you don't know it's skewed to the right, skewed to the left, but you know it's skewed, you need to talk about the 5-number summary. No mean, no standard deviation. If you talk about that, you better have the words roughly symmetrical in your description. Okay, does that make sense? I hope that makes sense to you. Hybrid B, they're kind of with me. I hope so. I hope you guys have a great day. Bye.